In the last lecture, we have discussed the rules of significant figures. Now we will discuss about the mathematical operations of significant figures. So let's start. First, let's see addition. Okay. So addition of significant figures have this one rule, that is the result cannot have more digits to the right of the decimal point than the original numbers. Okay. So the result cannot have more digits to the right of the decimal point than the original numbers. Now we will see some example, but before seeing some example, we need to say that the mathematical operations of significant figures have a very important common rule, that is math first, significance later. Okay. So we will have to do the math first, then we will discuss about the significance figure. So let's take this example. Okay. So here there are 4 significant figures and here there are 3. So we will do the addition first. So we get this result. Now the rule says the result cannot have more digits to the right of the decimal point than the original numbers. Okay. So we will have to see the number with the least significant figure or the least digits after decimal point. This has 2 digits after decimal point, but this has only 1. So we will have to decide by this number. So the result should have only 1 digit after the decimal point. Okay. So we can write this. We have to round off. Okay. So now we will have to remove 1. So 1 is less than 5. We know the rules of rounding off. So 8 will remain unchanged. So we get the result as 25.8. Okay. Now let's say 371.5328, 41.312, 331.1254. We will have to add them. So let's do it. This, okay. Now again, according to the rule, see, this number has the least number of digits after the decimal point. Okay. So this we have to maintain this rule. So we will have only 3 digits after the decimal point. So we will take these 3. Now we have to remove 2. Again, by the rules of rounding off, 2 is less than 5. So 0 will remain unchanged. So we get the result as 743.970. Okay. Now let's see another example. 15.72 plus 20 plus 31.923. Let's add this is the answer. Now, see, 20 has no digits after a decimal point. Okay. So, we will have to maintain this rule and the result should not have any digit after the decimal point. So, for rounding off, we have to remove 6. So, 6 is greater than 5. So, the preceding digit 7 will increase by 1. So, we will have 68 as the result. Okay. So, this was the addition of significant figures. Now, we will see subtraction. Subtraction also has the same rule as that of addition. So, let's try some examples. 0.856 minus 0.2721. So, this is the answer. Now, this number has only 3 digits after the decimal point. So, the answer should also have 3 digits after the decimal point. So, we need to remove 9. Since 9 is greater than 5, so we will add 1 to 3. Okay. So, the answer is 0.584. Okay. So, this is the final answer. Then another example, 312.28 minus 45.3216. So, let's do this. Okay, this is the answer. Now, this number has only 2 digits after the decimal point and this number has 4 digits. So, we will go with the least number. So, the answer should have only 2 digits after the decimal point. Now, this digit is 8. Since 8 is greater than 5, we need to add 1 to the preceding digit. So, we get the answer as 266.96. Okay. So, this is the answer. Now, we have learned about addition and subtraction of significant figures. We need to now learn about multiplication and division. So, multiplication and division has a common rule which says the result can have only as many significant figures as the number with the least significant figures. Okay. So, the result can have only as many significant figures as the number with the least significant figures. Okay. We will see this with some examples. So, let's say we have 2.5 multiplied by 3.5 0.021. So now this number has two significant figures, right? And this number has four significant figures. So when we multiply this, we get a result 8.8025. Now the number with least significant figures is this, which has two significant figures. So the answer should have also two significant figures. So if we take these, we will have to remove them. So we are removing 0. So this will remain unchanged. So we get the answer as 8.8. Okay. Now the next example is 4.32 into 0.021 into 16.3. So first we will do the math. The result is 1380.1536. This is the result. Okay. Now we will see how many significant figures are there. This number has four significant figures. This number has two significant figures. See, the 0 here is significant because it is existing between two non-zero number digits. But these zeros are not significant because they are on the left to the first non-zero digit. So they only signify the position of the decimal. So there are two significant figures and this has three significant figures. So the result should have two significant figures, right? So how will we write this big number into two significant figures? 2 means we will have to take these two and we will have to remove the rest. So we have to remove 8. So since 8 is greater than 5, 3 will increase by 1. So we can write this as 1400 point this. Okay. So this is the result. The result has two significant figures. Now we will see some examples of division. 5.1 by divided by 12.8. Okay. So first we will do the math. The answer comes as 0.3984375. Okay. Now this number has two significant figures and this number has three significant figures. So the answer should have two. So we will take these two and we will eliminate the rest. Okay. So 8 is greater than 5. So we will have to increase 9 by 1. So the answer becomes 0.40. Okay. Now we will see another example. 32.87 by 7.2. So we write the answer as 4.565277 and so on. Okay. So this number has two significant figures. This number has four significant figures, right? So the answer should have two significant figures. So we will take these two and we will remove the rest. So since 6 is greater than 5, the answer will be 4.6. So these were the mathematical operations using significant figures. Now we need to understand dimensional analysis. So what is dimensional analysis? We can see that for different entities, we have more than one unit system. Let's say the SI system for measuring length uses meter, centimeter, etc. Right? Meter is the SI unit. Now the other multiples and sub-multiples of meter can be centimeter, millimeter, kilometer, etc. But we can also measure length in terms of feet and inches, right? Now these two unit systems have a relation between them. Similarly, for measuring energy, the SI unit of energy is joule, but energy can also be measured in terms of calories. These two unit systems are interchangeable. So the method of changing the units of the same entity can be understood by dimensional analysis. So let's do this. Dimensional analysis. So, dimensional analysis does conversion of units from one system to another, right? So let's see an example. So we have to convert 3 joules to calories. Okay. So the relation between joule and calorie is 1 calorie equal to 4.2 joule. So we can write 1 calorie divided by 4.2 joule is equal to 1, or 4.2 joule divided by 1 calorie is equal to 1, right? So we have 3 joules. So 3 joules can be written as, so 3 joules means what? It is multiplied to 1, right? So this can be written as, since these values are equal to 1, we can replace 1 by either of these two. So let's say 3 joules into 1 calorie by 4.2 joules. So the value doesn't change because 1 is equal to this. Now joule can be cancelled, and if we do this operation, that is 3 divided by 4.2, we get, so let's see the unit first actually. If joules are cancelled, then the unit left is calorie. So if we perform this operation 3 by 4.2, the unit of this entity will be calorie. So we get the answer as 3 joules equal to 0.714 calories, or we can write 0.7 calories. Okay. So this is dimensional analysis to convert units from one system to another. We will discuss little more example of dimensional analysis, and then we will start about some laws in the next lecture. Thank you.